Welcome back, boys and girls. Good day to you. How do you feel today? I feel fine. Now the topic for today is on electronics. And the subtopic is using the transistor as an automatic switch. I'm sure all of us have used the night light before. You know, when we sleep, the light comes on, and in the morning when it gets bright, and the light goes off automatically. So that is an automatic switch in that special device. Now remember, electronics, some students find it a little bit complicated, and some of them are running away from it. But actually, we can learn anything. And I will try to show you how simple electronics can be. A quick reminder to all of you that to understand something well, you need to do rehearsal, you need to answer questions. It is more than just reading. If you just try to read and understand, you might not get very far, because once you have read it once, after that you need to keep on answering questions, you need to write down answers. You need to write it again and again to get the concepts into your system. Let us look at a question. And this question is very similar to past year questions in one way or the other. Diagram 10.4 shows a circuit with a transistor that acts as an automatic switch. I'll show you the diagram in a while. The transistor in the circuit causes the light emitting diode to light up when it is dark. Explain why. And intentionally I put there 4 marks, just like our paper 2. So this is the diagram. The transistor in the circuit, it causes the light emitting diode to light up when it is dark. So this is the diagram. Now we have to explain. Now to explain it, basically, for 4 marks, you need to explain just 4 points. But before you can understand this, basically there is something that you need to understand first before you can tackle this. You need to use the basics of electricity. And this is something that I'm going to make very simple for all of you. Uncle, I thought it's electronics. Why do you come back to this page again? Remember, I just said that we need some basic electricity to understand it before I can get back to electronics. So, please allow me to take 5 minutes to explain V equals to IR, a very simple concept. Then we will come back to that electronic circuit. Alright, that is a question given to us, and this is the diagram. As I said, we need electricity concepts to understand this concept, which seems very difficult. So basically what I would be teaching now is understanding the concept of dividing the potential difference. Now let me give you a diagram that is just next to this diagram. Alright, what I would like you to do is to look at a diagram something like this. Let's say here I have 12 volts. And let's say here I have a resistor. Here I have another resistor. And here I can call this resistor R1. I call this R2. I can call this or name this resistor having 10 ohms. The resistance is 10 ohms. And this one, it can be 30 ohms. Alright? Now, this is actually a very, very important concept. This diagram here is actually something that I need to explain to my students time and again so that they understand the other diagram. Alright? So you must be asking me, okay, what's up? Alright? What am I supposed to do? Again, what we call dividing the potential difference is this. Resistor R1 and resistor R2, actually they are dividing the potential difference of 12 volts. In other words, they are sharing the 12 volts. So I have got a very easy method for students to understand this sharing concept. Over here, we just ignore the negligible internal resistance of the battery. Alright, now what I'm doing is this. Look at the basic formula first. I will have to explain why I'm going to do certain things with these few cups in a while. Let me explain the physics first. V equals to IR. That was shown to us again just now. Okay? No problem with that? Now remember, now I am actually focusing on this circuit. Just leave the electronic circuit for a while. Look at the red one. R1 and R2, they are in series. So when they are in series, the electric current is common. It's constant. So since I is constant, we have V equals to a constant multiplied by R. In other words, V is directly proportional to R. This is very, very important. In other words, look at 10 ohms here again. The bigger the resistance, the bigger will be the potential difference across it. Now what do I mean? Alright, what do I mean? Let me just draw and show you. Alright, so here I have V1. And here I have V2. Alright, so what is the value of V1 and V2? Let us do ratio. R1 10 ohms, R2 30 ohms. So what is the ratio of R1 to R2? R1 to R2, what is the ratio? Strictly speaking, it is 10 ohms to 30 ohms. Alright? 10 ohms, let me write it again. R2 equals to 10 ohms to 30 ohms. Alright? So, in short, R1 to R2 is 1:3. Alright? 1:3. So, in this particular diagram, what I can do is, how much is V1 and what is the value of V2? So, I can actually put here one container. Over here, I put 3 containers. Okay. So, this is V1. One container. This is V2. 3 containers. Okay. 4 containers altogether. And how many volts are they sharing? 12 volts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wonderful. Alright. So, 1, 2, 3, 4. Each one will have 3 ringgit. Alright. Once we do simple maths, we know that this is 3 ringgit. I put in here. Here I put in 3 ringgit. Here I put in 3 ringgit. See, physics is simple. I told you so, right? Okay. 3 ringgit. Okay. So this is the one which is represented by one box over here. Alright. So how many volts should I be writing inside? How many volts is it? Yeah. Some of you giving me your hand signal. Alright. It is actually 3. 3 volts. So every single block is 3 volts. I can see you smiling. You're wondering, oh, physics so simple. Huh? Just playing with money, playing with boxes, put in the marbles, put in the money. So what do I have here? I've got 3 volts here. And V2, what is the value? I have got 9 volts. Alright. So, in other words now, what I'm doing is that I have got my final answer. V1 is 3 volts. And V2 is 9 volts. Now, this is the most basic thing that you must know. Without understanding this, we cannot go on to the transistorized switch, the circuit of the transistor. You need to know this. And once you understand this, then the next part, it becomes very easy as I go point by point with you. Okay, any questions? Alright, no questions. Okay, one of you shaking your head, smiling there, happy. Alright, when you're happy, I'm happy. Okay, so now let us go back to our transistorized switch. The question says, explain why when it gets dark, this light emitting diode will light up. Okay, so what do we do? So the first thing that we are going to write is when it gets dark. When it gets dark. Alright, we just write it. Take our time. Okay. Now when you answer a question like this, put everything in point form so that when you read it, you understand. It's just point by point. Alright, don't write a long essay, but just point by point. So when it gets dark, what happens to the LDR? The light dependent resistor. So this is the first thing we have got to ask. So what happens to this when it gets dark? We need to mention something about its resistance. So the first thing is that the resistance of the LDR increases. It becomes very big. Alright? So remember that in this circuit that you have here, alright, let's say this battery here has 3 volts. Let's say. Okay, we can give it a value. Let us say that here it has 3 volts. Now, before it gets dark, the resistance, or rather when it is bright, the resistance of the LDR is small. Okay? So when the LDR has a small resistance in the bright, you will know that the potential difference across the LDR is small. So now it gets dark. The resistance of the LDR increases. So that's the first point. And now we get back to what we have been talking in the past 8 minutes. When the resistance of the LDR now becomes very, very big, increases a lot, what happens now to the potential difference? I'll put it here. So now what happens to the potential difference across the LDR? Alright? So therefore, the potential difference across the LDR, does it go up or go down? Remember, look at the money here. Alright, the bigger the resistance, the bigger the voltage across the resistor. Okay? Can you signal to me by your hand whether the resistance of the LDR now, the voltage, whether it goes up or is coming down now? Does it increase or decrease? You can see that it increases, isn't it? Okay? So the potential difference across the LDR increases. Second point, which means that I get 1 mark here, I get 1 mark here. Okay, wonderful, very simple. 2 more marks to go. So when the potential difference across the LDR increases, we say that the base current increases. Alright, the base current increases, and when the base current increases here, alright, this is the base current increases. This will be the third point that we are trying to say. And when all this happens, what we get is that finally the collector current flows. The collector current flows and switches on the bulb. on the light emitting diode. So basically, these are the main points that we need to write, that we need to understand. But you will understand that this page, I explained it only in a short while, but what is most important is to understand the concept that the potential difference across the light-dependent resistor, the potential difference goes up or increases when the resistance of the LDR increases. So, when you see this page actually summarizes the whole story, why the light will light up when it gets dark. So for you, you need to go back and read it and understand it. Alright, so with that, I would like to say thank you very much again, and may God bless you.